Hello and welcome to this Numpy video. As usual, when I'm starting to get interested in a subject, I just come back on the basics and make a video so that if I can explain it, then it's that I kind of get it, right? So what is Numpy? Let's start by importing it. Obviously, you might need to do a pip install. Numpy is a library that's very useful for you to handle collections, arrays, and more complex sets of data, especially numerical data, but not only them. It's used because it's very nice and very fast compared to something like a Python list. It's going to be very comparable in the way you use it to Python lists, but it's going to be way more efficient. So let's first see how you create NumPy arrays, and then we'll see a few operations that go on with them. So NumPy is used to handle objects that are called scalars, vectors, matrices, and tensors. This is a mathematical subject that I don't master. I don't know very much about it, but it's just a way you categorize the kind of arrays we're going to handle here. So you might see those words come into play. A NumPy array is going to look like this. If I have my R variable, okay, I'm gonna call np.array and then open my brackets and set this structure. Before I do it, I want to go on something way more simple. I'm gonna call an array A and call np.array of just 1. And what's gonna happen here is that I'm gonna have A. A is gonna be an array that just has the value 1. If I call a.shape, which is a property of a NumPy array, it's going to tell me it's of a shape of 1 and nothing. And this is categorizing your array as what it is and what shape it has. You can see that up there we have multiple layers of brackets, and it's going to give a different shape to your NumPy array, and that's how you can kind of go into different kind of objects. This one digit, one element array is what a scalar is. It's just like this one dot, one spot somewhere. If I add multiple values here, I'm creating an array of a shape 4 because it's this one list of 4 values. Just like for a list, it's going to be going from 0 to index 3, and those indices are going to be what you're going to be using to access data in your array, because obviously a of 0 is going to be 1 and a of 2 is going to be 3, just like in a Python list. But where this is getting interesting is that if I add another list here and I go into 5, 6, 7, and 8 in my list, then I have a second dimension to my array. And instead of working with two different lists, I'm going to tell NumPy that this is all part of my one array, okay? And this array contains two subarrays that are 4 values each. So what happens if I do this? Then I get this 1, 2, 3, 4, 5, 6, 7, 8. What is the shape of this one? Well, it's 2 and 4. What does that mean? Well, you can see in the organization I have up there that I set my two lists in two different rows. It's better and easier for you to read it, but that's also the way that NumPy is going to read it too. Actually, this first value is going to tell you that you kind of have like two rows in your table, and this is very noticeable here. You have a row of 1, 2, 3, 4, and then a row of 5, 6, 7, 8. So this is row number 1, this is row number 2, so shape of 2. And then each of these rows are going to have 4 values, and so that means that you're getting 4 columns, okay? And that's exactly what makes NumPy so strong. You can handle tables of data and manipulate them in a very practical way, okay? We're going to come back on that a bit later. And then finally, what happens if I delete a value here? Well, Python is going to tell me, be careful, you have ragged nested sequence with different length or shapes. That means that you're actually having an issue if your different subarrays, if your different accesses don't have the same length, because the specificity of a vector, and this is what we're getting now, we have a vector, we have a matrix, sorry, I skipped to telling you that this is the vector because it's one collection of values, and then the matrix is a collection of values, if I could say it this way. So what we're getting here is two arrays that are not the same shape, that are not the same length. So if you want to do operations and manipulations on them, NumPy is going to struggle, because the strength of NumPy is going to be calculations and manipulation of those data that are anticipating the fact that everything is the same size. And so some methods of NumPy might not work anymore because you cannot interchange values, manipulate values, calculate stuff, because when they're going to try to find the equivalent of 4 in this array, they're not going to find it because the value at the same index as 4 in the next array doesn't exist. So it's very important for you to have arrays that are exactly the same columns in every row, just like that. And finally, for us to end up with our first array example, we have the D types. You have a lot of D types in your NumPy module, and that's just because you can tell NumPy what kind of value you're going to have. And here, by stating after my array that the D type is an np, so numpy.float32, I have numbers that are floats and that take up 32 bits of memory by number. I'm not going to go too deep into that, but if you have to handle memory and efficiency, you might start to worry about the types. And what's interesting is that you could see that I went from integers to floats. So you don't really care about the values you're inserting in your array, especially if they come from outside of your code or an outside document, because you can always tell NumPy what you're going to work with and they're going to adapt. Obviously, you're not going to always create arrays this way. You can do a lot of things. And what you can do is also use methods that are going to generate arrays and populate them in various ways. I'm not going too deep on this one, but for example, if you go np.once and that you ask 2, you're going to have an array which is going to be here a vector because it's an array of multiple values, and it's 2 ones. And if I add 10 here, it's going to be 10 ones, etc., etc. So it's very useful for you to generate a basic list of a certain length, a certain data type, and then do stuff on it. You might ask me, how do I get multiple dimensions array? Basically, it's going to ask you to add a tuple. If I can find my brackets again. To add a tuple, and in this tuple to give the shape of your array, just like there. So if I say 2, 4, I'm going to get exactly the same kind of shape as I had before. This way. And just as an example, you can see that if I revert it to 4 and 2, I'm going to have 4 rows for 2 columns, so 4 rows of 2 ones. This is for np.once. You can see that here my example went with start, stop, and step, because just like in the list for slicing and for NumPy methods, you're going to have to use start, stop, and step to tell them stuff. And this is something you're going to see if you use the method np.arrange. np.arrange is going to give you an array that goes from a value to the stop of your array, and then you can give a step for it. So for example, if I do an np arrange of 3 and 11, I'm gonna get an array that goes from 3 to 10 with a step of 1 because I didn't specify any step before, so I get 3, 4, 5 to 10. 11 is not included, just like you usually do in Python. If now I add a step of 2, I get 3, 5, 7, and 9 because I take every other value starting from 5. So easy as that, and very practical for you to create like arrays for any kind of a project, and for example for the x-axis of a plot. And finally, the last one I want to show you is called np np.linspace, which is even more interesting, and it works kind of like np range. Np linspace is going to take a start, a stop, and not really a step. So that's interesting. If I go 10 and 50, what I'm going to get here, if I press enter, is just like a lot of values that are going to climb in a linear fashion towards 50. So I don't know exactly why the amount of value, the standard amount of value, is this one, but I recommend that you always add the third argument, which is going to be the amount of values that you want in your linear array. And here, if I go from 10 to 50 with asking for 5 values, we're gonna have an array of 10, 20, 30, 40, and 50 because I asked for 5 values. Note here that the stop is actually inclusive and not exclusive like you have in most other methods. Counterintuitive for me, but I kind of get it because here you're filling in between those and you're not like iterating kinda. So yeah, it's fair. We went through data types, so I'm kind of okay with this. Now that you're kind of comfortable with how to create arrays and what they're made and their shapes, let's see things about operations. We're gonna use R again that we created earlier, and we're going to do operations on them. And that's the crazy and best thing with NumPy to begin with. It's the operations speed. You don't need to iterate through a NumPy array to do operations on it. If I do r.2 times 2, I'm going to get r times 2 in every spot, because when you do an operation on an array, you're operating on every single items of this array. And I could do the same by multiplying, adding, dividing, etc., etc. What's even crazier is that you can also do operations on other arrays. So how does that work? If I do a divide function, I'm going to call np.array, and I'm going to have 2 dimensions, and just be it's going to be 1, 1, 1, and 2, and the second one is going to be 2, 1, 1, 1. Okay, so here I have an array of 2 dimensions, 2 rows and columns of 4 values. What happens if I do r divided by divide? Well, you can see that I'm not changing anything until I get to my 4th value, where I'm going to divide 4 by 2 and get 2. And then I'm going to divide my first value here, 5, by 2, get 2.5, but I'm not touching the other ones. So having the same shape of an array is going to allow me to do operations specifically in the good spots of my other array. And this is where like it gets super interesting, right? Because you can now compare two data sets that are similar and do operations on them, compare them, divide them, and have insight. Here you can see that I increased the value of my 4 to 8 because I multiplied here and there. This is also why we talked earlier about shapes and having the same amount of data, because those kind of operations happened because the NumPy knew how to add those two structures together. And now, out of curiosity, even if I'm not really sure, let's see what happens if I have just a vector as my divide. Well, the vector is going to be applied at every rows of my array. Okay, so you could just have a vector that is the same shape as your as one of your rows and then apply it. But what happens if I add a 10 here? Well, there's going to be an error because the shapes of my arrays are not compatible for an operation, and I will need to remove this for it to work again. So this number of columns is very important for you to be able to do operations on arrays together. Finally, and I'll stop there for today, you might see that sometimes your arrays are not going to be compatible, right? But there are lots of ways to handle that, and for this we're going to come back on this notion of rows and columns and axes so that we can go deeper into slicing and concert. So the axis of your array. Let's create a new R array, which is here going to be of shape 3 and 4, so 3 rows, okay, for 4 columns. This is basically for you a table, and you have 2 axes. Obviously, we talked earlier about Numpy being about scalars, vectors, matrices, and tensors, and we're going to mainly see matrices because tensors are even more complex of an object. It's going to be like multi-dimensional, and it makes for even more complicated stuff. I believe that if you understand 2 dimensions, slicing, sorting, and axis manipulation, then you can go into bigger ones, and I'm still struggling with tensors, so let's just stay in this range for now. Let's maybe get a quick draw for this. So let me get my Epic pen here real quick, and we'll get into that in a second. Okay, so let's talk about what this table is going to be. So this NP array is going to be just like a table of that looks kind of like that, right? So you're doing this, and then you're going to have your column row 1, row 2, and row 3. You might have more, you might have less, and then 1, 2, 3. Okay. In this table, using the Python indexing, you're okay to say that we have here the column 0, here the column 1, here the column 2, here the column 3. Oops, that doesn't look like a 3, but it's okay. And here the column 4, for example. What happens if I add my values here? Well, I'm going to start at row 0, add at index 0 my 1, add at index 1 my 2, my 3, and my 4, but I don't have a 4th column, okay, because I start at index 0. Then I go to row 1. Row 1 is going to be 5, 6, and 7, okay, and finally an 8 to finish. Like I'm not going to be doing all of them all the time. And then my row 2, so this is the 3rd row, index 2, is going to be 9, 10, 11, and 12. Okay, so you've got a table in this Numpy array. The only thing you've got to understand with axis is that you're always going to talk about the rows first and go down there, and then you're going to handle the columns which are inside of your rows. And so if I want to access or reshape or slice my array, I'm going to first be choosing my row here. Okay, so if I'm going for the value 6 in my array here, I'm going to first go to the 1st row, so 2nd row index 1, and then I'm going to go to the index of 6, which is index 1 also. But if I was to go to 8, I will still go to row index 1, but then I would go to column index 3 to find my 8. This is everything you need to understand to have a basic understanding of your axes in Numpy. Okay, and so what does that give us? Well, you have multiple ways to handle those axes and to be able to do operations on arrays and make them compatible with each other. So starting with this array of shape 3 and 4, you can see that I have this function called reshape. Reshape is simply going to change the way your data are organized in the array, changing the shape of the array. So if we go from 3 to 4, what's going to happen? Well, what's going to happen is that you're simply going to translate, going to move every value to the next row, or bring back the values from a row to the previous row so that you fit the new shape. So you're basically just pushing or joining arrays together. So if I reshape my 3, 4 into 2, 6, I get this. I get 2 rows of 6 values instead of 3 rows of 4 values. You can see that we keep the amount. 3 times 4 is still 12. 2 times 6 is still 12. So we're keeping the array's core system in there, but we're changing the way it's displayed. And so you can see that 5 and 6 climbed up to row number 0, and then you had a second row of only values 7 and 8, making it able to absorb the row number 3 or row index 2 in itself, creating this shape of 2 and 6. Okay, so basically that's where we're at. What's funny is that we could add a dimension here, and I believe like this. No, my bad. Dimension 2, 3, sorry, yeah. Okay, and this is where we get into tensors and where it gets more complicated, but you can see that basically we have 3 dimensions, and you can see that by counting the amounts of brackets 1, 2, and 3, telling you we have 3 dimensions. And now our array is organized within 3 dimensions, a first dimension of 2, and then all of those 2 dimensions have 2 rows and 3 columns. Okay, so you can see that you basically have 2 tables, 1 and 2, in this tensor. Okay, just keep in mind that in the end, it just needs to keep the same amount of values. So 4 and 3 is just going to be 4 rows of 3 values, and this is maybe even easier for you to understand right now. And finally, before we finish off with this video, I'll keep on going next time, is reshape and transpose. Transpose is used with capital T in Numpy. You have other ways you can use the actual transpose method, but capital T is a way quicker way to do the same thing. So the difference between transposing and reshaping is going to be that transposing is about switching your columns into rows. And let me get back the epic pen for that, because I think it's interesting. If I get a table, okay, that is looking like this and has this column here and this column here and this row there, and then you have other columns and rows, what transpose is going to do is that it's going to take those values, the first columns, so your first row is gonna have each value for a column, and all those are gonna be, oops, that's a nice timing, thank you. My bad. So what I meant is, what I have here is a row, and this row must become a column. Okay, so if I have 1, 2, 3, and 4, and 5, transposing means that those are going to become 1, 2, 3, 4, and 5. So it means that all your rows are going to be transposed as columns, and the same way all columns are going to be transposed as rows. So if I had here 1, 2, 3, 4, 5, and then 6 here, okay, in this index, 6 would now be where? Well, it would be here, okay, because the 6 would be the new second column instead of being the new second row. Okay, let's just see what that looks like with the formula now. So we're gonna get rid of this. So I'll remind you that our R array looks like this right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. When we're going to transpose, it means that this row is now going to be a column. So what you're looking at now is that your new first row should be the first value of every row, so 1, 5, and 9, okay? And your new second row is going to be your second column, 2, 6, and 10, etc., etc. So transpose, and boom, we've got it. We've got a first column that is 1, 2, 3, 4, a second column that is 5, 6, 7, 8. Okay, so that's very useful because we talked about that. You are basically, just like in a Python list, going to be able to slice access your values. And if I do it now, you can see that if I do r dot 0, I get my first row of my first r, but if I do r dot transpose 0, I now get 159. So we're going to get into slicing, we're going to get into accessing the data later on, but this shows how with just this capital T transpose action, you can change exactly what you're accessing and what you're going to do calculations on in a very easy and fast manner. So that's going to be it for today. It's already pretty long. I'm going to get into the details of slicing later and some filtering, and then we'll just go into Numpy. It's pretty long, but I enjoy coming back on this because I learn a lot too, and that's basically why we're doing this, right? So I'll see you around. Bye.